So today we're going to look at adding and subtracting fractions. Just as you can add or subtract whole numbers, you can also add and subtract fractions. The main difference, however, is that all whole numbers can be added or subtracted from each other relatively easily because they're all whole numbers, whereas fractions can easily be made up of parts of different sizes. So here we have just a simple addition question made up of whole numbers. 2 plus 4 is 6. However, if we take these numbers and we put them on the bottom of these fractions, so take this 2, put it here, take this 4 and put it here, I can't just add it the same way. I can't say, well, 1 plus 1 is 2 and 2 plus 4 is 6, so 1/2 plus 1/4 equals 2/6. It doesn't work that way. If we look at these pictures, we can see how it does work. So if I have 1/2, well, here's this picture here represents 1/2. 1 out of 2 sections are shaded in. And if I add 1/4 to it over here, well, if you just imagine taking this little section and bringing it over to here, we're combining them, we're adding them together, it will look like this, which is 3/4. Now, having a visual like that, having those diagrams can help, but it's not always very practical. We don't want to have to always draw a diagram for every single fraction question. So if we look at just the fractions, 1/2 plus 1/4 equals 3/4. Now, I also wrote 1/2 as 2/4 here, which is a bit of a hint as to how we're going to add fractions. So if you just look at this question, 1/2, or also known as 2/4, plus 1/4 equals 3/4. So what do you notice about that? So hopefully you noticed that if we look at 2/4 here, we can simply just add 2 plus 1 is 3. One other thing you should have noticed is that the denominators here, we didn't add those. I didn't go 4 plus 4 is 8, it just stayed 4. Because if we read it out loud, it makes a little more sense. If I say 2/4 plus 1/4 equals 3/4, right? That makes sense. I wouldn't say it equals 3/8 all of a sudden because I just changed the unit. If I say I have 2 quarters or something and I add 1 more quarter to it, how many quarters do I have? Well, I've got 3 quarters. So we do not add the denominators. We just add the numerators when the denominators are the same. So if we're going to add fractions, we need those denominators to be the same. In order for them to be equal, we may need to find some equivalent fractions. If the denominators are already equal, then we can simply add the numerators and write the answer over the common denominator. So in the previous example, we saw that 1/2 is equivalent to 2/4. Now, we saw that when we drew the picture. It was a little easier to see. However, again, if you don't want to draw a picture every time, we need another method to be able to create equivalent fractions. So if I want my denominator to be 4, right, then I have to look at my initial fraction here, 1/2, and I want to figure out, well, how do I get 1/2? How to make this into an equivalent fraction that has a denominator of 4? Well, I need to either multiply or divide the denominator to get to my new number. And because it's increasing, it's going from 2 to 4, then I need to multiply, and in this case by 2. So if I multiply the bottom by 2, I have to multiply the top by 2. So that's how I create 2/4. So 1/2 is equivalent to 2/4. And the reason we do this, the reason why I want this in fourths, is because the other fraction that we were adding to this was in fourths as well. And it's easier to add fourths to fourths, just like it's easier to add, say, meters to meters. You want your units to be the same. So we're just going to look at a different example that actually doesn't use fractions, uses distances. So here it's possible to add, say, 35 kilometers plus 200 meters plus 1,500 centimeters. However, if we were going to do this, we would want them all to be the same unit, like either all be kilometers, all be meters, or all be centimeters, so that we can combine them. In this one, if I combined them all by using meters as my common unit, then 35 kilometers would become 35,000 meters, 200 meters would just stay the same, and 1500 centimeters would become 15 meters, so that when I added them all together, I'd get 35,215 meters. So just like when we add distances, where we want a common unit, it makes it a lot easier to add them. When we're adding fractions, we want a common denominator. Our denominator is like our unit. So here's an example. I've got 3/6 plus 2/5. Okay, so these are the steps that we're going to follow. Our first step is we want to find a common denominator. Right now we have a 6 and we have a 5, so we want them both to be the same. So we need to change one of these fractions or both of them so that they share a common denominator. Then once we have that, we can go ahead and add the numerators together and then write that answer over top of the common denominator. So in order to find that common denominator, I need to look at the first 10 multiples of 6 and the first 10 multiples of 5. So for 6, I would write them down: 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. And the first 10 multiples of 5, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And then I need to look for a number that they have in common. And I find out that 30 is in both of these rows. Now, if you kept on going, you'd find other common multiples, but we want to stick with the lowest one. That'll make it easier for us. So 30 is the lowest common multiple here. So we're going to use that as our common denominator. So I want to change 6 into 30, and I want to change 5 into 30. So by, again, either multiplying or dividing, well, because this is getting larger, going from 6 to 30, I need to multiply. So 6 times what is 30, and 5 times what is 30. And then when we figure that out, we'll do the same thing to the numerators. Alright, so in order to get 6 to turn into 30, I have to multiply it by 5. So if I times the bottom by 5, I have to times the top by 5. So 3 times 5 is 15. And for the other fraction, for 2/5 here, to get from 5 to 30, I have to multiply by 6. So if I times the bottom by 6, I have to times the top by 6. 2 times 6 is 12. So this tells me that 3/6 is equivalent to 15/30, and 2/5 is equivalent to 12/30. So now I can add these fractions much more easily. Instead of saying 3/6 plus 2/5, I can say 15/30 plus 12/30. And now that my denominators are equal, I just add the numerators. 15 plus 12 is 27, and I write that over top of that common denominator, 30. So the answer here would be 27/30. But I want to write it like this, because these are my original fractions. I would say then that 3/6 plus 2/5 is equal to 27/30. Now we're going to look at subtracting fractions, and the reason why I'm doing this, both adding and subtracting in one video, is because once you know how to do one, you can do both. Subtracting fractions uses the exact same strategy as adding fractions. So we're just going to do a quick little example here. So I'm going to do 3/4 minus 1/3. So step 1, want to find that common denominator. Step 2, make equivalent fractions that use that common denominator. And then step 3, we subtract the numerators. And lastly, we write that answer above the common denominator, just like we did with adding. Okay, so first up, got to find this common denominator. So right now I have a 4 and a 3 as my denominators. So I want to find the first 10 multiples of each of these. So the first 10 multiples of 4 are 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. And the first 10 multiples of 3, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. And of course, when you're finding these multiples, I don't expect you to have to do all the times tables in your head. If you know them, great. If you don't, then just go ahead and use a times table chart. Right now, we're just working on adding and subtracting fractions, and you want to use all of your tools that you have at your disposal. So when I've done these 10 multiples of each denominator, I want to look for that common denominator. I see I have a 12 here, so we're going to use that. We also have a 24 that's common, but let's use the smaller one. That'll make it easier. So I want to turn 4 into 12, and I want to turn 3 into 12. So 4 times what is 12? Well, 4 times 3 is 12. And 3 times what is 12? Well, it's just the reverse. 3 times 4 is 12. So this tells us what we're going to multiply these numerators by. So if we're multiplying this denominator by 3 to get to 12, then I also need times the top by 3. So 3 times 3 is 9. And for 1/3 over here, I'm multiplying 3 by 4 to get 12. So times the top by 4. 1 times 4 is 4. So this tells us that 3/4 is equivalent to 9/12, and 1/3 is equivalent to 4/12. So then I can say, because I'm subtracting, remember, that 9/12 minus 4/12 is 5/12. I just subtract the numerators and I leave the denominator the same. But again, the original question was 3/4 minus 1/3. So if 9/12 minus 4/12 equals 5/12, then that means 3/4 minus 1/3 also equals 5/12.